Okay, yeah, I did start the recording, so I will do that as we go through. And then I'll just, try to post this up, or I'll post this up in the announcement. So um, I hope, or I might have to email it. I'm not sure, because I know sometimes that in the past when I've posted these MP4s, they wouldn't load when they were too big. So I'll try to figure out what I need to do for you to have access to that. So might be just me emailing it to you as well. Um, I just wanted to quickly mention this. This is actually a T table and something that we're going to get to by next time. And like I said, I hope you don't think that what I did there was kind of a waste of time, because I hope we're going to benefit from it in the future. So you're not just trying to memorize a bunch of rote steps. But this stuff right here on the bottom, this value of Z, these will be the T statistic, which we'll get into. I figured I don't want to give you too much at one time here, but the next time, and plus I'm sure you're, running into it or encountering this in the videos. But, if I want to know, for like the Z distribution or the standard normal, these areas right here above for two tails, let's say if I want, 5% area in the extreme values of two tails. That means 2.5% in each of these tails. That means the Z statistic would be 1.96. So in other words, if I was looking at one of those curves here, I can actually jump back in here and do that. If I want to go to the between two values of 1.92, 1.96, left boundary should be negative, and the right boundary should be 1.96. You can see that I have about 95% of the area in between here, which means that this is 2.5 and this is 2.5. Okay, so that's kind of how that table works. All right. When we go back here, again, I'll just show you real quick now. The 1.96, 95 in the middle means 5% are on the ends, and actually that's the two combined, the two ends combined, and this would be the single end. Okay. So one of the things that we're going to be doing later on here using this is that when we have a fixed level of significance, in other words, if we predetermine when we run that, that problem or that hypothesis test and say, like I did in my example, they had a significance level of 0.01. That meant if your p-value is less than that, it gives you strict instructions of when to reject the null hypothesis. Okay. Sometimes we don't even need to know what the statistic is in order to figure that out or find the exact p-value, because for this instance here, if my Z statistic was negative 2.83, and I go back here, negative 2.3 over here would be way over here. Okay. It'd be right about here. Okay. Right where that arrow is flipping around here. So the idea is that, okay, I don't know what the area is here by knowing my Z statistic only, but I do know the area to the left of negative 1.96 is 0.05. So what that means is that now my p-value has to be less than 0.05. If I wanted to relate this to my example that I just did, and I want 1% in that left tail, I would come over here to this. My statistic would be, Z statistic would be 2.326. So if I come back over here, since that was a one-sided test, I'm going to go just to the left of a value, okay, negative 2.83. Oh, that must have been in there from earlier, but anyway, that was, oh yeah, that's what I had here. Let me go back to that table. What did I say that was? That was, if I put in negative 2.326, try this one more time. Let's spell that number right. Okay. All right. Notice that area is 0.01. Well, my test statistic turned out to be negative 2.83. Okay. So what that means is that I'm to the left of that. So my area has to be less than 0.01, which means my p-value is less than 0.01. Okay. And then that scenario, again, that I just described last session there, said that it gave me strict instructions with a significance level of 1%. If my p-value is less than that, I reject. Okay. So here, again, if I was using this technique and I just used the chart and I mentioned, what did they do in 1940 or 1930 when there was no software, they would look up this value on the table. It would go to 1%. Okay. And they would come down here and they would say, okay, if I move out 2.326 in either direction, to the left of that is going to be 1%. What that would mean is that I don't know what my p-value is, but I know my statistic is negative 2.83, which is less than negative 2.3. So therefore, I would reject it. Why? Because I know it's going to be less than 1%. I don't know what it is, but it's going to be less than 1%. Okay. Now, some of the reason I mention this is some of the problems are worded like that in ALEKS that we're going to run into here. Okay. So I will, like I said, get back into this here. And I don't know if Professor Springer ever showed you this, but I'm not going to get in and change things around. But I just want to try to pick certain problems here and use them as examples for you guys. Okay. So I'll tell you what will work out best here is if you, and I got the chat up here, so I'm going to, I guess, maybe ask for some participation here and ask you guys to maybe use the template here for some of these examples. And I'll go ahead and do the same, and then we'll kind of compare results. So we want to do a null hypothesis for let's see, for proportion using the p-value. So let's do that right now, okay? And I'll pick one of those we can look at here, okay? And if you're really lucky, maybe this is the exact problem you got, okay? But this is one like you'll have. And so as I'm going through here, and we'll just read this one together here. I got a calculator here. All right, that's cool. It does do. Oh wow. Okay. I didn't realize they had this built into ALEKS. Again, I never taught an ALEKS stats course. This is kind of interesting that they actually have calculators to find p and t values, which is pretty interesting. So I don't know if he may want you to use these, he may not. I don't know. Like I said, they tend to focus on the Excel. So again, not bad mouth, and I'm not a real big fan of Excel for that reason. He has a very, very nice, very extremely nice template set up for you, which basically functions like one of these calculators. But if you're just doing it raw in Excel, it's pretty challenging. So, all right. So what I'm going to do here is kind of go through and set this up. And it says, all right, so we want to state the null hypothesis and the alternative hypothesis. Okay, so again, this is what you're going to get to go by, all right? So we have marriage counselor traditionally seen that the proportion P for all married couples for whom her communication program can prevent divorce is 78%. Okay, after making some recent changes, she claims she can prevent more divorce or prevent divorce in more than 78%. Okay, so this is typical of what would be done where you have some sort of standard. We could just as easily say, hey, there's this drug out there that has a 78% chance of success rate, and we got this new drug now, and we're looking, to obviously increase that. And so, whether it's, the occurrence of divorce or something like that, that would be negative, obviously, or that would actually be a positive thing to increase that, right? But sometimes there's a negative, factor depending on the scenario. So but I don't want to throw too many things in here. So let's just stick to this one here. But I just wanted you to see that, like, we can apply this to a lot of different scenarios here. So our population parameter, we're hypothesizing. We have no idea, of all the people that she has and, that sort of thing. We're saying that, hey, if you jump in here, we can guarantee that. So we want to state the null and alternative. Now, just so I don't have to type all this stuff in, because what you're doing over here is just picking from these palettes here. Maybe I'll type in the first one here that, I guess I'll type out the equals, right? And then in the first one, I'm going to write P, which is my population parameter, is equal to 78%. And usually we use decimals when dealing with that, okay? And then my alternative, this is kind of the effect she's looking for, is to actually have P be greater than. So I probably should back that off and come over here and then select this. P greater than, actually it should be, yeah, greater than. Oh, I gotta put P off the top. I'm putting off the keyboard. Okay. All right. So that's that would be the first part of this. Okay. Now the next part would be to again, and I don't know, maybe you want to kind of write this down, or you can quickly try to find one that mirrors this also in your Alex set. I probably should have mentioned that earlier. I don't know what technique you like using. You can even take a screenshot of this. That might be a good idea to do that. And obviously, if you want this recording, you can go back. And like I said, I'll get it to you one way or the other. Okay, so the next thing it's asking me to use is what statistic. Okay, so the reason I showed you all that other stuff before is why we picked the Z statistic. Remember when I showed you that little P hat distributed normal with P in the middle, all that stuff, that tells me that, again, that I know that sampling distribution, P hats are going to follow that mound shape. That's why I did the simulation for you. Okay. And so now we're going to find the value of that statistic. Okay. So, so again, if you use, like I said, I guess we could use this calculator over here, but for the sake of being consistent and what they want us to use here, I'm going to kind of jump out of this and jump into your spreadsheet. Okay, so let me go ahead and do that. I guess I probably could figure out a way to get all this stuff crammed into one window, but that may be even more confusing. So let me go ahead and get into this master template here. Okay. All right. So when I do this, I will put in my hypothesized value, which again, hers was 0.78. Okay. And I believe we had 240 random couples. I hit 9. So, all right. So I have my 78% and my 0.4. The next thing to do is to find out what P hat is. So this is kind of an easy way to do this in Excel. You could hit an equal sign, and we want 192 out of the 240. Okay. So instead of doing that on a calculator separately, that's 80%. Okay. So if you did take 192 divided by 240, they give some nice neat numbers here, but that's okay. So 80%. All right. So it says find the value of the Z statistic. So we would just come right down here, and it tells us to round to 3 or more decimal places. Okay. So if I rounded that to 3 decimal places, that would be 0.748. So I'll try to keep one eye on the chat just to make sure that I don't I don't want to do that, because I want to type this in over here. I hope I didn't mess up my formula here. If I did that, I'm going to have to reload this. Okay. All right, so let me go back. I'm just gonna type that in over in that other window, point, make sure we don't give it. Point, what we say, Z statistics, 748. Okay, and find the p-value. So our p-value here, and again, we went around this to 3 decimal places because this is a right-sided test. It would be 0.227. Okay. All right. So I go ahead and I looked at the stuff over here, and and by the way, for my rights decision for a right tail test, it actually tells you it's failed or reject. So we would know that by you looking at using your template over here, the way he has this set up. So there must be some sort of logical test in there, which is kind of nice for you guys. Okay. But, up here, notice it has a 0.01 level of significance. So let's say if you didn't have this over here, and I'll go back to that other window in a second. But if you didn't have this to look at over here about whether to reject or fail to reject, what you, what you would have to do now is take this p-value right here, which is 0.227, and compare it to this. And if this number down here is less than that, we would reject. Okay. If it is not, then we would fail to reject. Okay. So in this case, we're clearly not rejecting this claim. In other words, there's not enough evidence to reject this claim and go with this. Okay. So our p-value kind of revolves around this idea. We're basing these calculations, and again, why I did all this stuff earlier, on the fact that the true average is 0.78. Okay, or the true value of p is 0.78. And if that's true, then the chance of us getting, which we got in our sample, an 80% or above is almost 1 in 4. Okay, well, that's really not unlikely. What's unlikely is, for us, this is our predetermined level is 1%. Okay, well, if we get to 1%, then we got something going on there. Okay, and so therefore that would be our criteria to reject this. So is there enough evidence to claim is more than 70%? Well, we would answer no. Okay, and check this and make sure we did this correctly. Okay, and sure enough, we did. Okay, so now I don't know how many of these he has in your particular assignment. Like these, I guess this one here, has a bunch of stuff in there. But let me just kind of go ahead here and leave that there for a second so you can look at that. And you can look at estimated time for these as being 17 minutes. I don't know, that may be a little bit too much, but it's just gonna be like anything else, guys. Once you understand this stuff, and that's why I'm hoping that other stuff pays off. It'll make a little bit more sense to you how you do that. So okay, so I've got my eyes on the chat here. Is there anything that I did there that you want me to go back over before we go over to maybe another example? All right, well, looks like nobody has anything there, so maybe that made sense to you guys. All right, so what I'm going to do is I'm going to jump out of this one, or do we want to try one on your own? Okay, so now here's a question you have to answer. I'm going to look at the chat here. Okay, do you guys want to try one on your own here before we go on and do another one? That means yes or no. Unless my chat's not working, nobody's responding. I gotta know. All right. Okay. So we'll do another. Thank you, Jeffrey. I appreciate that. Okay. So what I will do is I will jump out of this one here. And so this was, again, a hypothesis test for a population proportion using the p-value. Okay. Now, I mentioned, you're going to have to do one of these, and I think it's worth to, take a look at, there's problems here, like for instance, this one. I don't know if we need to do this one all the way, but this one will, oh wait, no, that's pretty much the same type of problem here. Sorry, that's using the p-value method. Let me show you one with the critical value method here. Okay, so because that was something I just recently talked about here. Okay, so you notice that this particular one here, again, same scenario here, right? Okay, I don't know, maybe your guys are all going to get that scenario. I don't know. Somehow, sometimes what Alex does here for these, but so we don't have to kind of reacclimate ourselves here, but again, we're looking now at a 77% rate, and the alternative being greater than 77. So, if I go ahead here and again, just quickly enter this stuff in, I always, for some reason, start typing that first, and I should put the equals first. So, and I got to get the P from here. I'll eventually get it. Okay, so here we want, again, greater than. So we've got P. Trying to type it in there. Okay, so really this is very similar except this part right here. Okay, because notice last time they wanted us to find the p-value. This time they want to find the value. Well, actually, we did find the value of the test statistic, but here they wanted us to find the critical value. Okay, so if do this correctly, should not take you long. Could somebody go back and get into that master? Why don't you see if you can do this real quick, because it's very similar to what we just did. Can you go ahead and put this information in the template here, the proportion template in your Excel sheet, and come up with the value of the test statistic? I'm going to go ahead and do that now, and I'll switch over here eventually. Okay, but okay, so I'm just going to say it. I got 77%. Okay, this is what I got for my p-value. So 0.774, which was kind of crazy. I mean, that's almost exactly right on the number here. Okay. But that should tell you something right there, that there's really no evidence, but we still need to find that critical value to answer this problem, and that's kind of the component that we're kind of missing here. Why I want to show you this. All right. So what I'm going to do here is just come over and oh, I guess I was off that sheet. Okay. All right, let me go back over. Okay. Sorry about that, guys. Okay, so here's the problem here, right? Okay, so so I got 77.4%, and there's the values, the Z statistic. So this is what I'm saying here. We were just looking at the template. We're going to fail to reject. We've got a huge p-value there, right? going to the right, I mean, it's really big here. It's like 44%, okay, which is not unlikely. Way over the one or 4.05, way over 5% here, okay. But to find that critical value now, I will switch over here to show you where I'm getting that. Okay, so if I could find the right screen here. I'm gonna find the right Google screen if I can. Maybe if I just do this desktop, that might be better. I think you should be able to see this desktop here. See both screens here, okay? And if I go over to this other chart here, I'm looking at now 5% on a right tail, so that's going to be this. So that's if I move over 1.645, okay? So again, because it's greater than, all this area for the p-value goes in one tail, okay? So I'm going to come back over here to my thing, and I'm going to put in the 1.645. Okay, and the question now to answer this is my Z statistic greater than 1.645? Because if it was more than this, I know the area to the right of 1.645, we can kind of see this column here, is 5%. So let's say my Z statistic was 1.645. Well, that would mean my p-value would be 5%, okay? If it's greater than that, that means my p-value is less than 5%, which would mean that I would want to reject this and say, yes, there is enough evidence. That's not more than that, which means my p-value is more than 5%. Now, if we remember back on the sheet here, I'm looking over at it, it says the right tail, in other words, to the right of 0.774 is actually 0.4439, okay, about 44%. And so therefore, obviously that's more than 0.05, okay? So, whoop, I'm gonna answer all the questions. So again, I'd answer no there. And, okay, what did I do? Let's see, find the value of test statistic. C is incorrect. I thought that's what it said here on, oh, I must have typed something in wrong there. I'm looking back over here. It's 0.141. Oops. Okay. Let me see if I can change that. I don't know where I got that number from. Okay, let me try that again. Okay, I must have been looking in the wrong box over there. I apologize for that. So anyway, our Z statistic is 1.141. And that kind of makes more sense. I should have realized that because 0.774 is really, really close to 0.77. Okay, so it's not that far from zero. So I should have picked up on that. Okay, so what we really did, today up to this point, and we're probably, getting to that point to wrap this up. I know I only got through two ALEKS examples, and I don't want you to be frustrated with that. But I kind of knew that that was going to go this way. And, like I said, it probably been, I don't know, if we would have met Tuesday, we would have had time to do more of these. But, even if we, keep the same schedule and, let you go Tuesday, looking at some more of the videos and hearing his explanations, because that's kind of what you're doing here with me right now. I'll spend all the time next Thursday working through these examples and making sure we get through lots of different questions, because what I tried to do today was give you the big picture and give you the whole concept so that you were able to understand, what it is you're actually doing. What you're going to find in the ALEKS, the rest of these problems as you go through them, as I, go back through here, some of these questions are just part of these problems, these two that we just did today. You might get, little bits and pieces of those questions in here, okay? So Now, if there's some in here, in the time being, I mean, if you want to send me, if you get stuck on these and you just can't figure them out, obviously you have the show me example, or I forget what it's called in Alex, but it'll give you some sort of explanation. But if you are really jammed up, you can send me an email or, a Halo message requesting, that I, give you some sort of explanation, and I will do that, either, written or video. I can, like I said, I could just have a quick Zoom meeting with myself and just send you a quick video with that. And I've done that in the past before. Okay. But we didn't get into testing means. So I'll do a much quicker, overall picture, because we'll be able to get through it a lot faster next time, since we have this as a basis. And then we'll do some of the other ones for population means. Again, the structure of the test is very much the same. The only thing that's going to change are the statistics. I will kind of give you a preview. Again, it's more of a teaching progression, but you'll have to do a test for a mean, and it is a z-test. And the reason it's a z-test is because the information they give you in the problem is they give you the mean and the standard deviation for the population. The practical problem with that is that, we are hypothesizing the mean. So that's not a problem for the statistic that we need to find there. The problem is we never, ever will know the population standard deviation. And so what happens then is we, instead of using the population standard deviation, we use the sample standard deviation. In other words, whatever numerical data we collect, we calculate that standard deviation, and that's what we use for the statistic. But it's not a z statistic at that point, it's a t statistic. Okay, so we're going to be using a t distribution, and t distributions look almost identical to the normal distributions. They're mound shaped, they're symmetric, the center is 0. As a matter of fact, all t distributions look like the standard normal. They center at 0. The only difference is that they are going to have a little bit different thickness, and I say t distributions in the plural sense, is based on the sample size. We'll use a different t curve for that. And the only difference between t curves are they all have centers at 0, but the tails in ones with degrees of freedom, and I'll get into what the degrees of freedom or degree of freedom is next time, is that the ones that have a higher degree of freedom are going to have skinnier tails, and the ones that have a shorter degree of freedom, degrees of freedom, are going to have a, if you will, like a fatter tail. So more of the area is going to be distributed in the tails. Okay, so I'll get into a little bit of that. That has an interesting historical note. I'll try to keep it as short as I can, but it actually has to do with Guinness beer, and we just passed St. Patrick's Day, and that's Scottish brewer from Guinness in Scotland actually developed a t-test. So it's kind of an interesting story, but we'll get into it later. If you want to look it up real quick, the guy's name is William Gossett. He's from Scotland. So anyway, so that's going to wrap up this class. I guess we're a little bit 5 minutes ahead, which I'm sure won't mind jumping out of here after getting out. But and I will, like I said, if you want that recording, I will try to get that to you. I'll see if it'll post. I'm not sure if something that long will post on the announcements, and if not, you can send me an email. I don't know, maybe that's what he does, is send you recordings and stuff via email if you want it. But anyway, that's that, and that's how you do those Alex problems. And like I said, next time what I'll do is I will be sure to do more of these next Thursday. So right now we'll plan on next Tuesday, you reviewing videos for your class time, and then next Thursday, more Alex examples, and that'll wrap up topic 5 homework. So I hope this was helpful for you guys. I just really encourage you, if there's something I'm missing or not getting, or something more that you want in terms of assistance, I'm kind of in a bad spot that I'm jumping right in the middle here. So I'm not really familiar with what you know and what you've done and kind of how you do things. So, I want to do my best to accommodate myself to what you're used to, as opposed to you getting used to me because I'm only going to be here for, 3 class periods. So I hope that was helpful to you. And like I said, I will see you next Thursday at 2 p.m. I hope you all have a blessed day. I will keep all of you in my prayers, and I'll see you next time.